Hello everyone, welcome back. Now we are in a position to discuss a new sensor, that is the PCA9536 with a buzzer. Now to gain more knowledge about this sensor, let's visit the website, that is controleverything.com, and here we have to search on for this particular sensor, and let's see what we got here for this particular sensor, that is PCA9536 I2C Digital 3-channel input output with a buzzer, and it's a I2C controlled buzzer, and you can see more prominent features of this particular sensor, and you can also have the privilege to add to cart or to purchase the sensor right from this website, right from here. Furthermore, I will be interfacing the PCA9536 with a buzzer using a particle photon, and the software platform will be a particle code, and to get your code we need to go to resource tab, and after that we can download the code sample from the particle code sample right from here. From this website, and you can also get the code from github.com, and the concerned repository there will be controlled everything community. Now what we're going to do is to show you how to connect some hardware connections, make some connections, and let's see what we got there. Well, coming to the hardware connection setup part, the first thing we require, which you are able to see on my screen, is a particle photon. Now this here is an I2C Shield. It's available and can be purchased from the website controleverything.com, and the reason we are using this shield is to make connections easier with other I2C devices. So for that, what we require is to gently place this particle photon over the I2C shield and make a connection just like that. Now to power up this particle photon, what do we require is a micro USB cable, which you can see on my screen, and gently insert it over this power jack. Next, we need our sensor, that is PCA9536, along with a buzzer. Now this here is a connecting cable. Now make the connection among the sensor and the cable, and make sure that the ground terminal of the sensor should be connected to the brown wire of the cable, and similarly to the ground terminal of the I2C shield. Now we are done with all the connections for the hardware. Now let's have a look over the code and let's see what we got there. Regarding the interfacing set, first of all we need to log into github.com, and after that we need to search on for the repository that will be control everything community. Then we have this, that is our sensor PCA9536-BZ, that for buzzer, and let's proceed with the particle code. But before that, give your intake on the instructions part, which clearly says that first of all we need to log into our particle photon, and we need to set up our device, and this link will help us to set up our device, connect up our device. And as you see, a lot of instructions need to be followed. Please do them, but carefully. And then we have to download or git pull the code, and on the online IDE we need to copy the entire code, and build.particle is the online IDE where we need to create a new file. We need to first of all paste the entire code, then we can have our saving. After that, as you notice, we need to verify and flash the particle code onto the particle photon, and we can have our output onto the dashboard in the form of logs, and this dashboard.particle will this link will help us to give our relevant output onto the screen. Now get back to the particle code, and it's a .ino extension file, as you notice onto my screen. The first thing you get your eyes on is that we have included some libraries, and as you notice, it's application.h, spark wiring I2C.h, and math.h, and we have defined the address of the sensor, that will be 0x41. Now in the void setup function we have set variables, and we have initialized I2C communication as master and serial communication with a baud rate equal to 9600. In the writing section part, first of all we have selected configuration register 0x03, and we have sent the command to select GPIO as input variable, which will be 0xf0. Now in the void loop function we have, in the reading section part, clearly exactly we have a for loop which will run 4 times, as you notice onto my screen, and in there we have to select the data output port register, that will be 0x01, and we are sending a command for logic high on each pin, that will be like this. Now in this part we have an if-else condition which will check whether the input output state is high and buzzer is off, or whether input output pin state is high and buzzer is on. So there are 2 different conditions which are working parallelly same onto this particular sensor, and to show and to see how it works, we're gonna go to the next part, that is the working part. Now let's have a look over the working part, which is to check the practicality of this sensor and the code. And the first step is to copy this entire code, and we have to move to build terminal we have discussed earlier. And here we need to create a new file here as we know it, and here we need to rename it as 9536, and buzzer will be the reference name, and let's save it. And after that we need to verify and compile the code, and it's a great work. Now we need to flash the code, and while flashing we need to check for the magenta flash, which will confirm that code is good to go and we can have our output on dashboard. Now let's open up dashboard link and we can have our output there. So as you are able to see and hear that we have for 0, 1 and 2 state buzzer is off, and for 3 state buzzer is on, just like that. So it's working as per you are able to hear and see, and this is how it's working. Now let's have a look over the applications and the features. The PCA9536 is an 8-pin CMOS device that provides 4 bits of general purpose parallel input-output, that is GPIO expansion for I2C-bus, SMBus applications, and input-output expanders provide a simple solution when additional input-output is needed for applications like ACPI, power switches, sensors, push buttons, LEDs, fans, etc. Well, you can have this sensor and you can purchase it from controleverything.com, and you can get the code from resource tab. From this site, you can download the code as zip file. Also, you can get the code from github.com, and the repository there is Control Everything Community. In the end, I would like to make it clear that if you have any doubt regarding any part of this sensor or video, you can have your queries on controleverything.com, and you can post your comments on the community page on this website. For articles and blogs, you can have a look over on instructables.com. And to subscribe more video tutorials like this, you can have a look over our YouTube channel. In the end, I hope you enjoyed this video and had a good one yourself. Thanks a lot for watching.